Okay, so let's take a look at these last two examples. So first off, I have two possibilities for restrictions. One is going to state that x has to be greater than or equal to negative 4 over 5. The other one is going to be x is greater than or equal to 0. I'm going to take that one. X is greater than or equal to 0. It's greater than the larger number. The second thing I need to do is I need to isolate one of the radicals. Well, I'm going to isolate the one on the left, and I'm going to subtract 5 from both sides in order to get it by itself. So I'm going to state that the square root of 5x plus 4 is equal to 2 plus root 3x. I'm going to square both sides, and I'm going to get on the left hand side 5x plus 4, and on the right hand side 2 squared is 4. 2 times root 3x times 2 is going to be plus 4 root 3x, and root 3x and root 3x are going to just give me 3x. Now I still have a radical in here, which means I need to isolate it, so I'm going to move everything else to the left hand side. I'm going to subtract 4 from both sides. Well, that's going to cancel out my 4's, and I'm going to subtract the 3x from both sides and say that 2x is equal to 4 root 3x's. Now, because I don't want to create any fractions before I square it, I'm just going to square at this point, and I'm going to state that 4x squared is equal to 16 and 3x, or 4x squared is equal to 48x. Because I have a quadratic, I'm going to move it to the left-hand side. 4x squared minus 48x is equal to 0. Divide everything by 4, and x squared minus 12x is equal to 0. Or when I factor this, I have x and x minus 12 are equal to 0. X is either going to equal 0 or 12. When I check them, the 0 fits into this restriction range, the 12 fits into that restriction range, so now I just need to actually verify in both cases and see if they work. So I'm going to start by saying that if I have the square root of 5 times 0 plus 4 plus 5 is equal to 7 plus the square root of 3 times 0. Or, that's going to cancel out, that's going to cancel out. The square root of 4 plus 5 is equal to 7. 2 plus 5 is equal to 7. Or 7 is equal to 7. And the 0 definitely works. I'm going to check the second case. The square root of 5 times 12 plus 4 plus 5 is equal to 7, and the square root of 3 times 12. The square root of 60 plus 4 plus 5 is equal to 7 times the square root, 7 plus the square root of 36. The square root of 64 plus 5 is going to equal 7 plus 6. 8 plus 5 is equal to 13, or 13 is equal to 13. And this is the first case we've gotten where they actually both work, which is a possibility. All right, last case. So, first off, I'm going to state that the restrictions are either going to be x is greater than or equal to 3 or x is greater than or equal to negative 5. Well, the x is greater than or equal to 3 is going to cover all my bases. I'm going to isolate one of the radicals. Doesn't really matter, so I'm going to move that root x plus 5 over and say that root x minus 3 is equal to 4 minus root x plus 5. I'm going to square both sides, and I'm going to say that x minus 3 is equal to 4 squared is 16, 4 times negative root x plus 5 times 2 is going to give me negative 8 root x plus 5. And negative root x plus 5 times negative root x plus 5 is positive, and then just x plus 5. X minus 3 is going to equal, well, when I am combining the like terms here, then I have the 16 minus 8x root x plus 5 plus x plus 5. I can move the x's to the left. Well, x minus x is just going to cancel out. I'm going to take the 16 and I'm going to, negative 3, I'm going to subtract 16 and I'm going to subtract 5 from that, and I'm going to get negative 24 is equal to negative 8 root x plus 5. And I'm going to divide both sides by negative 8. 3 is equal to root x plus 5. And then I just square them again. Which means that 9 is equal to x plus 5, or 4 is equal to x. And I just have the one case I need to check. Well, 4 fits it within my restriction. 4 is greater than or equal to 3. So when I check it, I'm going to say if I have 4 minus 3 plus root 4 plus 5, does that in fact equal 4? The square root of 4 minus 3 is 1, plus 4 plus 5 is 9, is equal to 4. 1 plus 3 is equal to 4. 4 is equal to 4. And there's my solution, and it works. All right, that is it. There is some extra practice here, and like with the other case, I will be posting what the solutions are for these if you want to double check and see if you got it correct. Okay, that is it.